half adder is the units. Okay, so which has actually two inputs. So one we call that xi, the next one you call yi, which is just 2 bits. We call this as a half adder. So we are talking actually about the half adder. Okay. So this, whenever you add 2 bits, so definitely you need the output should be 2y, because if the both of them is 1, so the output is 1 0, so that means definitely 1 bit is not enough in your output. Definitely that should has actually 2 output. I call one si, so the next one ci plus 1. Okay. So in the lab, we just accept these as a unit. But today, after you learn about the design combinational circuit, you could design that. If I tell you, okay, this is a design problem. I said, okay, design a half adder. So you say, okay, I need a circuit with 2 inputs and 2 outputs. So then you start your design. You say, okay, I want to design a circuit like this, able to add the 2 actually inputs. I have 2 inputs, X and Y. So each of them could be 0 and 1. I have 4 different cases, which is 0, 0, 1, 0, 1, 0, 1. Okay. So then what should be the output? I call this output Ci plus 1 as a 1 bit. So somehow this is an index. Okay. So this is Ci plus 1. And the next one is Si. Okay. This is exactly a design problem. So then you say, okay, we actually know the steps whenever you want to design any circuit. So then, okay, I need to complete this truth table. Whenever they are is 0, 0, this is half adder. It should be add 0 plus the 0. The output should be 0 and 0. Okay. So whenever the x is 0, y is 1, it's adder. 0 plus 1 should be actually 1. So these bits should be 1. These bits should be 0. Okay. So whenever you add again 1, 0, the same thing. It should be 0. This should be 1. Whenever the both of them is 1, so you should have 2. So that means these bits should be 0. This should be 1. So just be careful. This is 2 power 0, 1. And this is 2. That means 2 is 1, 0. Okay. So then you say, okay, I have this. Then what I did whenever I design, I need to actually find these outputs based off these inputs, standard form, right? So I start with the SI. So you say SI equal. The SI definitely is a function of X and Y. You already know that. Equal to sigma midterm. Which midterms? You tell me. SI is here is 1 and 1. It should be which midterms? Which midterms? Midterm, this is what's the number of this? Yeah, it should be 1 and 2, definitely. 1 and 2. That's a standard form that. Then I make that simple, which somehow you don't need to that because this is just 2. So I just want to follow the steps that we have in the design. Also, this is very simple design problem. So the Ci plus 1 again is the function of X and Y. It's equal to which sigma. Just you have 1, which is 3, right? M3, okay? So technically, you don't need to have a Carnot table because if you even do that, so you are not finding any square which is they are in the same boundary, right? I could do that, but definitely it's not necessary. So here for this, you already know there is no need for the K-map because you just have one midterm, right? So what's the corresponding term for M3? You just write the M3. So you say Ci plus 1. So what is the M3? So you already know what is the M3 is XY. That's it, okay? So that's this. How about the Si X plus Y? If you want to even use the K-map for this to get the very simple form. So the K-map for the function with two variables should be just had 4 square, right? So you put x here, y here, because you just have to. You put 0, 1 here, 0, 1 here. So what is this number is 0, what is this number is 1, what is this number is 2, what is this number is 3. So 1 and 2, so you have 1 here, you have 2, sorry, you have another 1 here, okay? So you tell me, could I get one set with 4 members? The answer is no, because there is nothing here. Could I get one set with 2 members? Yes or no? Based on what you see here. Could I get one set with 2 members? Yes or no? Just type on the text box. So do we have any sets? Yeah, definitely is no, because this is not adjacent with this, right? They don't have any common boundary. So that means you have to keep this and keep this. Okay, so then write the term of Si equal to this, which is midterm 1, should be x prime y plus x prime y. So x prime y, that's right. For this, the x is 1, should be x, and the y is y prime. Okay, so that's it. So do you actually able to design the half adder? So see, you say, okay, whatever you actually saw in the lab right now, you get the enough basic knowledge to design that. You say, okay, whatever I put here as a unit, it's this circuit. So you just need to have SI, which is this. How I could implement this? This is actually the XOR, right? So I could do this. I could let's see what we could do. Let's do the our this form, which is x. I put the prime here, have one for y, and it's not definitely is y prime. Okay, I start with the si. So this is the XOR, right? If you take a look, this is exactly XOR, right? So the first prime plus the next one no prime, then next prime. Okay, so it should be XOR, one XOR. Its output is Si. So what should be its input? You already know. Should be just X and Y. So see X and Y. What is the XOR and X and Y? Is X prime Y plus Y prime X. That is exactly what you have. You just put the XOR there. So how about the Ci plus 1? You just need the AND, right? Put AND here. The output is Ci plus 1. And if you check the inputs, it's just X and Y, okay? So this is X and this is Y. Technically, I don't need to have this X prime because there is nothing for that. That's it. So if you actually implement this on your breadboard, so you actually made one half adder, right? So that's actually why these designing tools is very powerful. Right now, you could design whatever you want. So that's for this case, we actually have the half adder. So in the summary, the half adder is a unit with 2 inputs and 2 outputs, and it's able to add these 2 bits and give the output. Okay. So if someone says, okay, what is this circuit? Design the circuit. This is answer for that. You're already able to design and say, okay, with this combination, I am able to make this unit. So why this half adder is important? Because in our next class, we will actually combine the half adder, we make the full adder, which is able to make add 3 bits. So then we use actually full adder to make 4-bit adders, which is able to actually add to 4 bits number. Then you could use 2 4-bit adder to make 8-bit adder. So that means this is the basic unit. Whenever you have these unit, then you could combine too many of them and you could able to add any numbers with any digits that you have. Okay. So I think it should be enough for today.